Alright, so in this lesson we're still going to be talking about scatter plots and trend lines, but we're actually going to look a little bit more into the correlation coefficient and kind of what the correlation is, and we're going to talk a little bit more about what all that plays in. So let's take a look at our I can statements. We're going to be able to create exponential as well as linear trend lines of a scatter plot, and we'll get into exponentials a little bit later. But analyze residuals, those are the correlation coefficients, to assess the fit of a function, whether it be linear or exponential. And then lastly, I want you guys to be able to compute and interpret, and we will be using a calculator, the correlation coefficient of a linear or exponential fit. Well, there's a big word in all those I can statements that says correlation or coefficient or residuals. Well, that term is actually going to be represented by R, because to write out correlation coefficient all the time would be rough, so we're just going to call it R for residual. It measures the strength and the direction of a linear or exponential relationship between two variables on a scatter plot. This number will always be between a -1 and a +1. So let me just give you 6 examples here, and hopefully it will kind of make a little more sense. I got A, B, C, D, E, and F here. Let's take a look at A. Let's take a look at this relationship. If we were to sketch a trend line through this, we could hit every single point. This is what we called a perfect negative correlation in one of the last videos you were supposed to watch. So that's a very strong relationship, but it's also negative. Well, the residual, or R value, the correlation coefficient we would choose then would have to be negative. And so I got 2 options here. I got -1 and -0.94. Well, because this is a really strong relationship, we're just going to go ahead and call -1 because it is a perfect relationship. -1 and +1 would both be perfect relationships, but different directions. Let's take a look at B. B. Well, I do have a good strong relationship. You can sketch your trend line through that, but I'm unable to hit all the points with my trend line, and 3 points above, 3 points below is what I have. That's the best you can do. Well, it's still a negative relationship, but it's not as strong as a -1 or a perfect relationship. So we got to choose a negative number. That's the only one left. So we're going to go ahead and put R equals the residual or correlation coefficient is -0.94. Now this next one, this is really hard to see. I think the most we could do here on C, I don't know. This one's rough. There's a lot of points. This is basically no correlation, or what we would say is that the correlation would be 0 or really close to 0. So I've got 2 numbers here, 0 and 0.08. Those are really close to 0, but I'm taking a look at F here. I don't know if that's going to be positive, negative. I don't know what's going on here. There's all kinds of crazy there, so I'm probably going to save 0 for that one. No correlation here. And then I'll probably give the R value of 0.08 here, because it almost looks like it might be positive, but not really. So we're just going to stick 0.08 there. I would understand if you maybe switch these 2 around, but I'm just going to go with that. So let's go on and move on to D. Well, it's the positive relationship, and yep, you could sketch a line that hits all those points fairly easy. So that's positive, and it is a perfect relationship because you can hit every point with your trend line. E. It's also a positive relationship. Can't hit all the points with your trend line. You can hit a few of them though. It's pretty strong. Those points are all pretty close to your trend line, so we're going to call that the 0.86. And again, just one more review of this slide. Correlation coefficients happen between -1 and a +1. The negative or the positive will tell you the direction, whether it's going up or going down. And the closer to 1 it gets, the closer all your points are going to be to your trend line. The closer your correlation coefficient gets to 0, on the other hand, the more spread out your data is going to be from your trend line. If it is 0, you're going to end up with something like this, or even something crazy like this one here. So Let's talk about this. Think about it. And I really encourage you guys to pause the video and to think about these questions, okay? It says, how close is close enough to -1 or +1 to indicate a strong enough linear relationship? Remember, they go between -1 and +1. So think of a number line here. A number line here from -1 up to +1, with smack dab right in the middle would be 0. The 0 is no correlation, where -1 would be negative and perfect. That's really strong. And this one would be positive, perfect. And that's also as strong as it gets. So how close do you need to get to +1 to be considered a strong relationship, or to -1 and be considered a strong relationship? Do you think 0.2 would show enough? What about 0.4? Or 0.5? Or 0.8? Well, most statisticians, people that work with stats or statistics all day, don't even bother with any correlation data that is even between -0.5 and 0.5. So 0.2, that's weak, if any. 4, also weak. 0.5, that could be argued as moderate, if you will. But basically, once you get above 0.5, like 0.8, you're showing a strong relationship at this point. I would even consider 0.7 and even like a 0.65 or something like that to be pretty strong. But the closer we get to 1, or -1, would be really strong. So numbers like -0.8 or +0.8, or even 0.7, positive 0.7, or a positive even 0.6 probably would be considered strong. Anything below that, though, like 0.5 is probably low, 0.4 is definitely low, 0.2 is low, but basically shows no correlation. 0 itself is no correlation at all. So let's move on to our calculator so we can actually calculate these R values. I highly recommend that you guys write these steps down, because either I'm not in the classroom with you, or you're watching this at home, and you might need this again. Yeah, you could pull up the video, but having these steps laid out somewhere written that you could follow will be really helpful. So I've got a table here that I need to enter in to my calculator. Make sure that you reset your calculator, and then we're going to go into something that we've never done before: second catalog diagnostic on. So that's going to be second button, catalog, which is this program button right here, and then we need to scroll all the way down to diagnostic on. It is in alphabetical order. You see here I have diagnostic on and diagnostic off. Choose diagnostic on and hit enter. If you do not do this, it will not tell you the R value of your data. That should be the first thing you do, after resetting your calculator, of course. The next thing we need to do is go into our list and enter our X values into list 1 and our Y values into list 2. In this case, X is going to be the price per shirt, and Y is going to be the number of shirts sold. So we're going to go into list and start typing our data. I'm going to speed up this part of the video so that you don't have to wait for me. Also, you need to enter in the second part, this list right here, the Y values, into list 2. So I'm just going to hit the right arrow and enter those numbers in, starting with 200. Alright, so here is where I need to stop for a second and talk about this formatting. Right now, I've got everything lined up exactly how I need it to be. You'll notice here, up at the very top of the table, the first point is 50, comma, 200. Well, if you scroll up on your calculator up to the top where it's 50, this needs to be 50, and then right next to it needs to be 200. If you don't have this, your data in your scatter plot as well as your correlation coefficient is going to be all screwy. So let's make sure everything is lined up properly as well. 44,250, 41,300, 33,380, 31,400, 24.5450, 20,500, and then 14.5550. That looks good. So next thing we need to do is go into our plots, which is second y equals. It's going to take us into our plots. We're going to go into that first plot up there, turn on our plots, and we're going to leave it as this first type. That is a scatter plot. We've looked at box plots before. These last two, we're not going to choose those. We're going to choose this first one and make sure it's looking at list 1 and list 2. The X list is list 1, that's our price per shirt, and our list 2 is number of shirts sold. So what we're trying to see here is there a relationship between the price for shirts and the number that are sold. Okay, once that's done, we can go ahead and go to graph and look at our scatter plot. Hit that graph button. Nothing shows up though, so we do have to do the zoom and then zoom stats. So the zoom button right here, and then option 7 for zoom stats. And there's our data, guys. So what do we see here? Well, we see a negative correlation, and it looks pretty strong. And if we were to sketch a trend line through that, that would be a fairly strong correlation. Okay, so that's one way you can quickly sketch a scatter plot instead of doing it by hand now. So let's take a look at drawing the actual trend line through our graph now. That should be kind of exciting. So let's do follow these steps. I got the same table here. I'm going to use the same data. We're going to go second, stat, calc. So second, stat, which is the list button. Go over to calc. And then we're going to be doing the linear regression. It's lin reg, and then it says ax plus b. It's option 5. That's all. Don't hit enter yet because we actually want to get the trend line equation and store it into our calculator. So we have to go second vars. This is again new, so pause the video if I'm going too slow. I'm going to hit the second button, and then we're going to hit this apps button right here. Right above it, it says vars. That's what we want to go into. And these are all of our variables that are actually in the calculator themselves. You'll see one here that says y vars. It is option 2, so we're going to go down to that. Hit enter, and then we're going to choose y1. And I'll show you why in a second. Okay, press enter. And you'll see it gives me an equation. It says y equals ax plus b. We're used to seeing this as y equals mx plus b. So a is actually going to be the slope here. And then it says a equals negative 9.91, and I'm just going to round to the nearest hundredth there. And then it says b equals 698.4, I'm just going to round this up to 43. Okay, so we actually can write an equation for our trend line now. That's y equals a, which is negative 9.91, x plus b, and b is 698.43. This is the equation to the trend line. Now this is actually kind of exciting, and I'll show you why in a second, but I want to go back to the calculator and explain why we just did this. Okay, so give me a second before we do that. We also have some r values here. R equals, not r squared. R squared you'll talk about later in school, probably in, I don't know if you're going to get into that in AP stats or what, but we just want the r, not r squared, r. It says that r equals negative 0.9979, and that's good enough. Generally I'll just take 2 decimal places, but if you rounded that would give you negative 1, which is a perfect correlation. And if you remember back in your graph, this was a very negative correlation, and it was pretty straight. So it would make sense that it's close to negative 1. This is our correlation coefficient, the r value. This is our equation to that trend line. What this correlation coefficient tells us is how reliable this trend line is. Go ahead and go back to graph now. And this calculator now actually has that equation stored into the calculator, and it will now graph the trend line for me. You can see that line basically hits every single point. Some of them are a little off, but they're really, really close, hence the really strong correlation coefficient. So, here are some of the questions you're going to be asked to answer. Write an equation that represents the trend line. Well, we just did that, right? We got this equation right here. Y equals negative 9.91x plus 698.48. So we got this equation from it already. So we've got y equals negative 9.91 plus 698.43. That is an equation that represents the trend line. Well, what is the correlation coefficient? Well, we got right here negative 0.9979, basically negative 1. If you guys want to round to the nearest hundredth, then you can just say negative 1. Or if you really wanted to, you could just say negative 0.9979. And this, again, tells us how accurate our trend line is. This is very accurate because it is really, really close to a negative 1 or a positive 1. I would say even 0.8 is fairly accurate. Now, the next two questions are probably the most confusing, but what we can do is use our trend line to actually use predictions now. It says use the equation to predict how many shirts would be sold if the price is 55. And remember, our price per shirt is our X value. So we're saying when X equals 55, what is how many shirts? Well, that would be Y value. So what does Y equal? Y equals what when X equals 55? Well, we have an equation here, guys. So Y equals negative 9.91x, which X in this case is going to be 55, plus 698.43. Use your trusty calculator and type that in. It says negative 9.91 parentheses 55 there plus, and then 698.43. So what is this number? It says Y equals, so we're going to have 153.38. Well, let's put this into context really quick. This is answering the question, how many shirts would be sold? Well, first off, if this is the answer, we can't sell 0.38 shirts. We ain't cutting up a shirt and selling a sleeve. That's not going to happen. So maybe you'll say 153 shirts, or maybe you'll say 154 shirts and account for that extra one. This is our prediction. We're probably going to sell 153 or 154 shirts if we price them at $55. Well, what if I price them for 18? Well, use the equation again. Y equals negative 9.91. This time the price is going to be $18 plus $698.43 here. And then just type that into your calculator. $520.05 is a horrible 5. 520 shirts-ish. So about 520 or 521 shirts we would sell if we priced them at $18. Now we did some interpolating with this one. This is called interpolating. This would be extrapolating. Extrapolating because we went outside this domain here. And then the other one, $18, is interpolating because it was within that range or domain. And that's how you're going to answer these questions. It's fairly simple. Now, how accurate is this trend line going to be? Well, it's fairly accurate because of our correlation coefficient. But let's say I went ahead and said $1,000 per shirt. Well, if I priced the shirts at $1,000, I would get this. I would sell negative 9,211 shirts. That doesn't make sense to sell negative shirts unless we are paying people to buy our shirts. I don't know. That doesn't make sense. So obviously we can't go too far from our domain. Basically anything from 14.5 to 50. We don't want to get too far away from that. Even pricing shirts at $0. Obviously we'd probably get rid of a lot, and I don't know if you'd call that selling them though, because we're not actually making money. So remember, trend lines are only as accurate as they make sense, but they're only as accurate as their correlation coefficient makes them as well. Okay, guys, this is it. You guys have a worksheet to work on. You guys are going to type that data into the list 1 and list 2. Make sure your diagnostics are on so you can find the correlation coefficient. So do that worksheet, get it done, and again, ask questions if you need any help. Thanks, guys.